Problem number 5. When 10 to the 93rd power minus 93 is expressed as a single whole number, what is the sum of the digits? Alright, well, let me give you a hint first. Probably the best way to start looking at this, 10 to the 93rd is a 1 with 93 zeros. Alright, so we have 1, and then we have 0, 0, 0, 0, 0, 0, 0, 0, and so on. 0, 0, 0. 93 zeros, and we're trying to subtract 93 from it. Okay? So my guess is you probably don't want to really do that subtraction. Now, you could. You probably don't want to write out 93 zeros, but my hint to you would be to look for a pattern. You could start with something like this. You have 10 squared is equal to 100, right? And if we subtract 93 from that, we would just have 7. 10 cubed is equal to 1,000, right? A 1 with 3 zeros. And if we subtract 93 from that, what do we get? We'll get 7, and then we'd have to borrow to get to do that subtraction, and then this ends up being 9, and this ends up being 9, right? I'm trying to cross out the whole thing. Okay, so 9 minus 9 is 0, and then we have 9. Okay, so 1,000 minus 93 is 907. So let's take a look at 10 to the 4th. That's equal to 10 with 4 zeros, which is 10,000, minus 93. Okay, we could do something similar with that. So this becomes 10, 9, 9, and 9. So we would end up with 7, 0, 9, 9. So you can start to see a pattern in what's going on. The more zeros you add, the more 9s you get out at the front. But the last two digits are always 0, 7. Okay? So that's my hint, is to look for a pattern, and as you take 10 to higher and higher powers. Okay? You could also do something like this. You could write out this and put some dots for some of the zeros, and then you could subtract 93. Pretend like you're actually going to do this calculation, and you'd have to borrow to make this 10, and then these would all be 9, 9, oops, and so on, 9, 9, and this would be 9. Okay, so you're going to get 7, 0 with a bunch of 9s. Okay, 9, 9, 9. Alright? So you could think about it that way. Alright, so I'm going to go ahead and solve this problem. I practically have it solved right now, because you can see when you subtract 93 from a power of 10, you end up with a number ending in 7, 0, 7, and then you have a number of 9s out in front. Okay, so you have 0, 7, and a bunch of 9s. So how many 9s are you going to have? For 10 to the 3rd, you've got 1 9, right? So there's 1 9. 10 to the 4th, you have 2 9s. So I bet you can guess at 10 to the 5th, you're going to have 3 9s. So the number of 9s you have is just 2 less than the power of on the exponent on the 10. So 10 to the 93rd is minus 93 is going to have how many 9s? It's going to have 91 9s. That's 2 less than the power, or than the exponent on 10. So that'd be 91. And we want to add up these digits, right? So we'd have 91 nines, all right? So when we add those up, we'd have 91 times 9. And then we're going to have a 0, and then we're going to have a 7. So we just add 7 to that. So 91 times 9, so 90 times 9 is 810, and then plus more and more 9. So that's 819 plus 7, and you're going to get 826 for the sum of the digits. All right? So there you go. Just look for a pattern as you increase the power of the exponent on 10, and you'll figure it out.